Today we are taking notes on Section 5, which is Proving Triangles Similar by SSS and SAS. Previous to this video, we have proved triangles similar using AA, angle, angle. As you can probably guess, SSS is side, 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 and SAS is side, angle, side. So our first theorem is the SSS similarity theorem. This theorem tells us two triangles are similar if all three pairs of corresponding sides are proportional. If two of the sides are proportional and the third one's not, they're not similar. You have to check all three pairs of sides. The SAS similarity theorem tells us two triangles are similar if two pairs of sides are proportional and the included angles are congruent. So we heard of included angles with the SSS congruency theorem, so proving triangles congruent. The included angles are the angles that hold together the two sides. If I'm going too fast, please make sure you pause the video so that you can write the theorem down. Here's our first example. It asks, are the triangles shown similar? If yes, write a similarity statement and state which theorem or postulate you used. Before we learned AA. Today we did SSS similarity. I write the tilde so we know we're talking similarity and not congruency. And then SAS. In our figures, we don't have any angles at all. So it's not going to be AA or SAS. Our only option is SSS. So I need to determine if my sides are proportional. The first ratio is smallest side goes with smallest side. So 6 over 8, and I'm going to mark that these are the smallest sides. I want to know if this ratio is equal to the ratio of the medium sides, which would be 9 and 12 in this case. I'm putting equal signs because I'm not sure if these ratios are equal yet. And then last one is our largest sides, which are 12 and 16. And I'm just going to mark that these are the largest. Now I need to simplify these ratios to see if they're equal. 6 over 8 simplifies to be 3 over 4. 9 over 12 simplifies to be 3 over 4. 12 over 16 simplifies to be 3 over 4. All three are equal, so all the sides are proportional. Therefore, yes, the triangles are similar. So to answer the question, yes, they are similar by the SSS similarity theorem. And lastly, I need to write myself a similarity statement. So triangle GHF, and remember, the order of the second triangle is very important. When I do GHF, I go to the smallest side, and then the middle side, and then the largest side. I want to do the same thing on my second triangle. Smallest side, middle to largest side. So that's IJK. Okay, next you're going to do two examples on your own. So pause the video right now, take 2 or 3 minutes, determine if the triangles are similar. If they are, tell me which theorem you used, and write a similarity statement. When you come back, we will complete them together. Okay, welcome back. Remember that the different ways to show similarity are AA, the SSS similarity theorem, and then the SAS similarity theorem. In this first example, we have two sides and angle. So we might be using SAS. This angle is not the included angle. The included angles in this case would be X and A, because those are the two angles that hold together our two sides. Because we can't use SAS, we can't use SSS, we don't have three pairs of sides, and we can't use AA because we don't have two pairs of angles. So we cannot prove that these are similar. It's possible that the triangles are similar, but we cannot prove that they are. Second example, we have 3 pairs of sides, so it looks like we might be using SSS. So let's check our proportions. Smallest side on the first triangle is 6. Smallest side on the second triangle is also 6. So I'm going to do 6 over 6. I want to know if this ratio is equal to the ratio of the medium sides. The middle sides on the first triangle is 12. second triangle is 8. And then just for fun, let's do the largest sides also. Largest side on the first triangle is 15. Largest side on the second triangle is 10. So I want to check if these proportions are true. 6 over 6 simplifies to be 1. 12 over 8 simplifies to be 3 halves. These are not equal. Therefore, our triangles are not similar. Okay, let's move on to our last example. Okay, so example 4 says find the values of x and y that make triangle PHS similar to triangle GEO. I have 3 pairs of sides, so with this we're going to be working with the SSS similarity theorem, which says all the sides should be proportional, or all the corresponding sides should be proportional. From our similarity statement, we know PH should be proportional to GO, so PH over GE, I'm sorry, I think I said O. And then we have HS should be proportional to EO. And then finally, PS should be proportional to GO. Remember to always go off of the similarity statement. You can't just guess from looking at the figure. Now I'm going to fill in these proportions with the information from the figures. PH is 4, GE is 12, HS is 8, EO is 2 multiplied by y, add 2, and then PS is 8, and GO is 18. Oh, no, I missed one. PS, I'm sorry, is not 8. It's x subtract 1. Sorry, my fault. Okay, now we're going to need to set up 2 sets of proportions so that we can solve for these variables. First, I'm going to look at this proportion to solve for y. 12 multiplied by 8 is 96. 4 multiplied by 2 is 8. And I still have that y add 2. Distributing the 8, I get 8y add 16. Subtract 16, we have 80 is equal to 8y. So y is equal to 10. Now let's solve for x. I'm going to need to use this ratio, and then I can either use this ratio or this ratio. I'm going to choose this one because I already have 4 and 12. So rewriting, I have 4 over 12 is equal to x subtract 1 over 18. 18 multiplied by 4 is 72. This is equal to 12x subtract 12. Adding 12, I get 84 is equal to 12x. Divide by 12, I end up with x is equal to 7. So here we've gotten x is 7 and y is 10. Quick review before we end. We know 3 ways to prove similarity now. AA, which is showing that 2 pairs of angles are congruent. We have SSS similarity, which is showing that 3 pairs of sides are proportional. Remember that it has to be all 3 sides are proportional. And then we have SAS, which is showing that 2 pairs of sides are proportional. And the included angles are congruent. When you come into class, we're going to do some examples with all 3 of these theorems.